Good evening, sir. Here I am B. Pujita from CAC B section. I am explaining the topic about JK flip-flop. Next, we can see the outline here. Introduction to JK flip-flop, flip-flop overview, symbol and inputs, truth table, circuit diagram, timing diagram, applications of JK flip-flop, practical example and conclusion. Next, here we are moving to introduction part. The JK flip-flop, also known as the Jack-Kilby flip-flop, is a sequential logic designed by Jack Kilby during his tenure on Texas Instruments in the 1950s. This flip-flop serves the purpose of storing and manipulating binary information within digital systems. Definition: flip-flops are basic memory elements in digital electronics used to store binary data. Importance: fundamental building blocks in sequential circuits. Types: SR, D and T and JK flip-flops. Next, we are moving to JK flip-flop overview. Here we can see the diagram of the JK flip-flop. JK flip-flop, a versatile flip-flop that overcomes the limitations of the SR flip-flop. Comparison: unlike SR, it has no valid state. And next we are moving to JK flip-flop symbol and inputs. Symbol: J and K inputs and outputs are Q and Q dash. Description: J and K determine the state change on the clock edge. Next, we are moving to truth table. Here we can see the truth table of the JK flip-flop and we can explain this. Q of T represents the current state of the output. Q of T plus 1 represents the next state of the output and Q dash of T plus 1 represents the complement of the next state of the JK flip-flop truth table. Next, we are moving to explanation of the truth table. JK flip-flop comprises four possible combination of inputs: J is equals to 0 and K is equals to 0, J is equals to 0 and K is equals to 1, J is equals to 1 and K is equals to 0, J is equals to 1 and K is equals to also 1. These input combinations determine the behavior of flip-flop and its outputs. J is equals to 0 and K is equals to 0, the first case. In this state, flip-flop retains its preceding state. It neither sets nor resets itself, making it stable. J is equals to 0 and K is equals to 1. These input combination forces flip-flop to reset, resulting in Q is equals to 0 and Q dash is equals to 1. It is often referred to as the reset state. J is equals to 1 and K is equals to 0. Here flip-flop resides in the set mode, causing Q is equals to 0 and Q is equals to Q dash is equals to 0 and Q is equals to 1. It is known as a set state. J is equals to 1 and K is equals to 1. This combination toggles flip-flop. And next, we are moving to basic functionality of the flip-flop. JK flip-flop operates on sequential logic principle, where the output is dependent not only on the current inputs but also on the previous state. There are two inputs in JK flip-flop: set and reset, denotes by J and K. It also known has two outputs: output of complement denoted by Q and Q dash. The internal circuitry in the JK flip-flop consists of the combination of logic gates, usually NAND gate. Next, we are going to use the circuit diagram. Here is the circuit diagram of the J and K are inputs and Q dash are outputs. Here is a CLK, clock, and next basic implementation of using NAR gate, NAR and NAD gate. Okay. Next, the JK flip-flop diagram above represents the basic structure which consists of clock, clear, and preset. Below the circuit diagram in JK flip-flop, three input NAND gates are used in this, and two output NAND gates and two input NAND gates. These outputs are Q and Q dash are coupled to each third gate. Next, we are moving to timing diagram. Here is the timing diagram, and I am explaining this in next slide. Here are the timing diagram explanation. Input signals J and K. These represents the control inputs to the flip-flop. When both J and K are low, the flip-flop holds its state. When J is high and K is low, the flip-flop sets Q is equals to 1. When J is equals to low and K is equals to high, the flip-flop resets Q is equals to 0. When both J is equals to 1 and K is equals to 1, then flip-flop toggles its state. Clock signal. This is the signal that controls when the flip-flop reacts to change in the input signals. The flip-flop typically responds to the input signals only when the clock signal transitions from a specific state to another. Next, we are moving to output states Q and Q dash. This represents the current state of the flip-flop. Q is the normal output and Q dash is the inverted output. Timing relationships. The timing diagram shows the relationship between the input changes and clock transitions and output changes. Illustrates with the flip-flop capture the input values and its output accordingly. Applications of JK flip-flop and practical examples. Applications: counters used in binary ripple counters. Next is shift registers used to store and shift data. Advantages: flexibility in various sequential circuits. Example: 4-bit binary counter using JK flip-flop. It is a practical example. And explanation: how each flip-flop output serves as the clock input for the next. Next, conclusion. In summary, JK flip-flop are essential components in digital electronics, providing versatility and flexibility in circuit design. Their ability to store state, toggle outputs, and perform various logical operations makes them invaluable in a wide range of applications, including data registers, dividers, state machines, and counters and shift registers. With their straightforward operation and reliability, flip-flops remain fundamental building blocks in moderating system. Thank you.